So we have a number of templates, PRD template, SRD template, 3 FMEA templates, and a hazard analysis template. The FMEAs, there are 3 of them, but they're really the same thing. It's just how you apply them. But the more complicated the product, the less likely you're going to be able to hit all the things that you really should hit. And on really complex products, you have to go this direction. On something really simple, yeah, if your product is a PC board that does 2 or 3 things, I'm sure you could handle all that just on a, back of an envelope and decide, well, I should guard this input or something. But for stuff that's really complicated, you really need to go through the process. So we've talked about the requirements documents. We don't have to talk about that.
We talk about RTM and RTM requirements, but from a medical device standpoint, there is a specific RTM checklist that we go through, which is similar to other RTMs, but it's more stringent, it's more documented to talk about too. And that could be another thing, just in the medical device piece of it, what separates medical devices from ISO 9001 standard manufactured devices? There's a bunch of little nuances there.
Yeah. The only problem with going into something about medical devices is that the medical device QMS that's put in place is highly dependent upon the product.
Yeah.
And what you need to release is highly dependent on the product. And it's hard to have some omni procedure to handle all cases. And I almost don't want to do that, because that everyone who would really want to see what our opinion is on that, unless they're just learning about it, if they really know what they're talking about, they'll find something to complain about. Oh, you didn't even talk about that because that affects my product. Well, yeah, of course it does. But it's up to you to bring that up to us and say, hey, this is important about my product. Oh, well, we'll have to handle this. That one could be dangerous. If we take it like an introduction and, leave it like there's a lot more depth to this depending upon the details of your product. But especially for startup companies, if you're doing a drawing for a machine part, there's things that you should consider about what needs to be on that drawing. And we have so many people that just take a SolidWorks drawing and drop their part into it and say, auto dimension that baby to 3 decimal places because, oh, wow, look at that. It looks beautiful. Ship it. And it isn't even close to being ready. And, but it is a drawing. You can show it to your boss and say, look, it's a drawing, and we'll send it off to the supplier and everything will be wonderful. And no, that's not true. There are people that would say, well, I'm a pretty talented engineer, but I lean more electrical. And because I'm the only engineer in the company, I have to do this mechanical drawing. And I'm not thinking of anyone in particular, Mike. But I don't know what to put on a mechanical drawing, so I'll just put what I think should go on there. And then when people complain, I'll update the drawing.
Right.
And the problem is you really jeopardize the quality of your product, because the supplier might not complain. They might just say, well, they didn't say to put a finish on it, so mill finish it is. And it's not what you wanted, but it's what you asked for. And that's a problem. And it's a problem that causes potentially months of delay in getting the product out the door. So what usually happens is they say, oh, well, we'll use it as it is anyway, and ship it and worry about it the next time. And when the next time comes, you've forgotten that you needed to put a finish spec on that part. So it rears its head again. When you look at engineers who are doing a design, everybody knows that you should have a design review. You should sit down, you should have the design that you've come up with reviewed by someone else, questions can be asked, assumptions can be challenged, you can defend the work that you did, and good ideas show up, and minor tweaks and changes or whole redesigns come out of a design review, but it's always to make things better. And everybody feels better coming out of the design review. I make these changes and it's going to solve this problem and that one that I didn't see coming because I wasn't working on that section of it. And you have a lot more confidence in your design. So then you make a drawing, because the drawing is what's going to explain to the person who's actually making the part what your intent was. So you can think in your mind that this is going to be a part and it's going to come out and it's going to be painted a certain color with a certain texture on it. But if you didn't know how to describe that on the drawing, you're not going to get what you were thinking about. So we have a document review checklist where once you've got the document made, you can print it out if you want to. You can go through this checklist and you could say, okay, the checklist says, just for the heck of it, is my company name, address, and contact information on this drawing? And you can look and say, oh shoot, I forgot to put that on there because I was very interested in the tolerancing of something. I didn't even put our name on the thing. What about your proprietary information statement? Oh shoot, if I don't do that, my CEO is going to kill me, right? Remember, no one's seen this drawing and you were just about to zip it up and send it out to a supplier. I'm going to say people generally put a title on the drawing because, what part is this? Oh, it's the bracket, left side, right? But do they put a drawing number? I want to think everybody does. Sadly, I have been surprised. Revision. They come without revisions from many companies. So we never know. Oh, I'll send you the updated one. Okay, well, what's the revision of the updated one? They're like, well, it's the one that I just sent you in my email. Okay. So then you get it, and you can tell the difference between the two if you looked and found out, what it was that they changed. But now it's sitting in your downloads folder, and which one of those is actually the one, and how are you going to make sure that that is the drawing that gets out into the field rather than some drawing that your purchasing person just sent to a supplier for quote? Now what are you going to do? Now the part you want actually made is different from the one that's being quoted. So now it's left the building and it's sitting at some supplier with no revision on it, and you're going to send them another copy with no revision on it to say, oh, we're using this one, not that one. It's out of control.
Or a bit of a corollary to that is we get a document and what revision in it? Well, it's the final revision. And then 2 days later, we get another one. Well, this is the final revision. It's the final revision. Or we get the updated revision, and then we get the updated revision, and then the updated revision. It's like, guys, you can't have 4 updated revisions. I don't know which ones you want.
And I kid you not, another one in here is the default dimension system, like inches or millimeters, and a default set of tolerances. We had a product quoted. We were told, oh, can you just quote these drawings? And we looked at it and there wasn't a lot of information on it. And the guy was in a hurry. He said, just send them out and get a quote. And some part came back and it was really expensive. And even I was shocked at how expensive it was. And the trick was someone had calculated the weight and it was many, many, many hundreds of kilograms. And I thought, okay, something's gone off the rails here. And it turns out that they had done it in millimeters, and the drawing was done in millimeters, but the dimension on the drawing was inches. The default dimension was inches. So something that was this big was all of a sudden 25 times bigger than that. And I should have seen it right off the bat, but I wasn't reviewing the drawing and doing a design review on the drawing. I was just getting it quoted for the guy. And if he'd had this checklist, he just said, "Oh, the dimension system. Oh, shoot, I didn't note what that is. I'll write down its millimeters and problem would have been solved." God help him if he said, "Well, it's expensive, but," because you know what, millimeters to inches, that's a factor of 25. But you could have done it so that it was centimeters to inches, and now it's only a factor 2.5, right? And someone might have said, "Well, it's a little expensive, but have him make one." Well, something 2.5 times bigger than what you were expecting isn't going to fit.
Hmm.
And then it would have been, well, of course it was centimeters and not inches.
Take a sheet metal part and a machined part. Well, they might both be made out of aluminum, but there are tons of different grades of aluminum, different types of alloyed aluminum. And some lend themselves to being machined, and some lend themselves to being bent up to sheet metal. And we got a document in a couple weeks ago, and I was reviewing the document. It wasn't my document, but I was reviewing it for dimensioning and tolerancing and all the feature sets. I was reviewing it, sent it out to the supplier, and I got a little bit of feedback from them a couple days ago. They said, "Hey, this is sheet metal, and you made it out of, or you want it made out of that aluminum that isn't a sheet metal aluminum. Do you really want it bent up like that? Because it's going to be really expensive." And I went, "Oh crap, no, make it out of the standard sheet metal aluminum. That's what I want, you know." But to John's point, that's one of those things when you do these reviews where a second set of eyes can be worth its weight in gold just to look at and challenge assumptions on these drawings.
Yeah, there's a lot of like we do machine parts, you know, there's a check mark here, material type and grade or specification. So this is where you would tell them exactly what that material is. And a lot of people forget to put that on the drawing. Sometimes they'll do a sheet metal design, but they'll leave the drawing format that still says 6061 T6, which if you bend it, it will crack. So the sheet metal shop is going to take one look at that and say, "Nah, they screwed that up," and call us back. But it could be more subtle than that. It could be, you know, just the tempering specification is off a little bit, and you're getting the wrong grade, or it costs too much because you've picked a material that was close, but not quite close enough. Sometimes it's you pick the material out of a book because, wow, this is really great, but you can't buy it, or if you can buy it, it's really expensive. And the truth is, yeah, it's a great, nice material, and boy, would it do the job. But there's a much better material that is far more available that will do the job just as well. And those are the kind of things that you need to think about. And if you don't have a way to go down a list and say, okay, what about the material spec? Well, you're right, I didn't really decide what would be the best on that. Now's the time to nail it down. Even if you want to call a supplier and find out, hey, what do you think is the right material for this kind of a part? They may have good input, but it needs to be written down on the drawing. Surface finishes, bill of materials. Sometimes a part like a piece of sheet metal will have PEM nuts pressed into it, and the sheet metal shop will do that. But now it's not strictly just a piece of bent metal with holes drilled in it. Now it's kind of sort of an assembly, but it's not really an assembly, but it actually is an assembly, right? So you need to detail exactly what helicoils or dowel pins or inserts or PEM nuts do you want installed where and how. It's the kind of thing that it's very easy to forget about. And all it does is it balls up the process. So we've put together a bunch of checklists that you can go down to make sure that if you need ROS compliant material, because God help you if they plate it the wrong way, you need to say that on the drawing, and you need to be able to put a note to that effect. It reminds you, oh yeah, think about that. Oh, it reminds you that, do we need to write the part number on the part so that during assembly or during service, you've got a record of exactly what that part is. It's got the part number and the part revision on it. Some companies do it that way, is they will print the part right on the part. And it all depends upon how their manufacturing processes are set up. With ours, we have the part bagged and the labels on the bag. But not everybody does it that way. For us, every part's got to be in a bag, or a bunch of parts will be in a bag. And that's not a problem until someone empties the bag out. And if you've got a bunch of parts that all look the same and someone empties them all into a big pile, well, now you got to be able to sort them. So some companies say, nope, we just put the part right on we put the part number and the revision right on the part. And that's how we absolutely positively know we've got exactly the correct part going in. So, but these things need to be thought of. And what we find is, especially startups coming out of with a CAD model, they're so used to just emailing the step file to some guy in China and getting a part in a box a few weeks later, that it doesn't occur to them that they need to do it any other way. But when you really want control over the part, and you don't want the grade of aluminum or the tempering of the aluminum changing from shipment to shipment, then you need to nail all that stuff down. So these checklists that we've come up with are a way to do that.